Hello again. We're graphing quadratic functions, and we're going to use tables again. Like I said though, we're going to get to a point where we're not going to use tables anymore, but I want to use tables on this specific example. And this one has x squared plus bx plus c. It's got a b in it now, it's got something with an x, and that makes the problem a little bit more difficult. Well, this one is not so difficult actually, but it does make it a little bit more thought-provoking. There's a few things you have to realize here. The number in front of the x squared is a. The number in front of the x is the b. And the number by itself without a variable is the c. The number in front of the x squared is 1. The number in front of the x is 4. And the number in front, the number without a variable is the c, which is also 4 in this case. What we want to do is we want to figure out if this graph is going to go upwards or downwards. And since it's a positive graph, it's going to go upwards. Okay, not so bad. But we can't use 0, well, try to make it a little bit easier first. We can't just assume we can use 0 in the middle of a table. And the very simple reason why is because we don't actually know where the vertex of this graph is. It's not at 0 this time actually too. And there is a formula that we can use to find the vertex. Now we didn't do it the first few lessons because there was no term with there was no b term to worry about. There's no term with just the x. So since there was no term with the x, we didn't have to worry about that. We just assumed it was 0. I'm like, yeah, this is easy. Well, this one's not so easy. In order to figure out the vertex of this graph, you have to use a formula. It's not too bad of a formula. It's x equals the opposite of b over 2a. Now b is 4, so the opposite of b is, and if this is negative 4, the opposite of b is 4. That's why I always say opposite b and not negative b. So the opposite of b is negative 4 over 2 times my a term, which is 1. 4 divided by 2 times 1 is the same thing as, negative 4 divided by 2 times 1 is negative 4 over 2, which means negative 4 divided by 2 is negative 2. That's my vertex. That's the middle value of the table that I got to work with. That's pretty much it. So what we're going to do is we're going to create ourselves a table. We create a table of 5 points. And I just like doing 5, and the vertex value always goes in the middle. Now, as I said, the vertex goes in the middle. So that's negative 2. Now we're going to go values to the right and values to the left. And we're going to go by whole numbers. So after negative 2 is negative 1. And the higher number than negative 1 is 0. Higher number than negative 2 is negative 3. And one more is negative 4. Now, since these are exactly the same distance away from the vertex, the y values will be exactly the same. Since these values are exactly the same distance from the vertex, the y values will be exactly the same. So I don't have to sit here and figure out what all 5 of the values are. I only actually have to figure out 3 of the values. And what we're going to do is we're going to start with our vertex. So we substituted negative 2 into this equation to figure out what it is. So y equals, I'm going to substitute in, now whenever you substitute, you put in parentheses, negative 2 squared plus 4 times negative 2 plus 4. I'm going to go ahead and do that really quickly in my head, and you can do that in your head or in your calculator, it doesn't matter. That's 4, that's 4, that's 8, that's negative 8, so that's 0. Now I told you that these values are the same because they're exactly the same distance away. If they weren't the same distance away, then the values wouldn't be the same. So you got to make sure that your values are always the same distance away from the vertex. Always. If you don't, it messes up your graph. And which one do you think is easier for me to substitute in, negative 3 or negative 1? Or actually I should say for you to substitute in. Negative 1 would be easier. So I'm going to substitute in negative 1 squared plus 4 times negative 1 plus 4. So when I do that, I know negative 4 plus 4 is 0, plus 1 is 1. But this value is exactly the same distance away from the vertex, so it's 1. Now you can check if you want to, and I promise you it will work. Now, I have a choice of substituting in -4 or 0. That's a clear-cut choice. 0 is much easier to substitute in. This is also why I put in parentheses. So instead of looking back at the equation, say, okay, I'm putting in 0, so every time I put parentheses, 0 plus 0 plus 4 is 4. Now, few things that I want to get straight. The vertex value is the middle value. It's the middle x and y value. So my vertex, which I'm going to notate with a V for vertex, is at -2, 0. It's going to be my lowest point in my graph because my graph is going to go up and my vertex is in the middle. My axis of symmetry is the x value for the vertex. That's all it is. It's the x value for the vertex, which is at -2. So I've already answered that without even graphing, but you can go ahead and check the graph if you want to. And we do have to graph. So I got to go -4 that way. I don't go anywhere here. Now I'll show you a way, without ever graphing, to figure out what this looks like. And it actually involves factoring, which I think is quite fascinating, but that's my opinion. So at -4, it's 4. And you have your graph. Now, there's a few other things we can tell from this graph. The axis of symmetry is at -2, which we already figured out. The vertex is at -2, 0, but I told you you didn't even need to do that. What happens if somebody asks you for the y-intercept? Where does it hit the y-axis? Well, it hits the y-axis at 4, but you actually never need to know that. You don't have to graph to figure that out, because your y-intercept is always whatever the c value is. That's always what it is. So your y-intercept is equal to 4, so we'll circle part of that too. Your solutions, or your x-intercepts, are where it hits the x-axis. Well, it only hits the x-axis at -2. So my solutions, or my roots, or my x-intercepts, is at, you can write it as -2, 0, but I tell my students it's just x equals -2. Some people like putting -2, 0. I don't care, personally. So I just say x equals -2. So your axis of symmetry and your vertex value for the x value is the same. Your vertex value is the low or the high point, depending if it goes up or down. Your y-intercept is where it hits the y-axis. And your x-intercept is where it hits the x-axis, which is right there. We're going to do one more using this type of method, and then we're going to stop using tables and really get into some advanced thinking in terms of quadratic functions, which I think is very fun. Hopefully you will too. But with that said, have a great day. Goodbye.